Hello, everybody. I hope you are doing fine. In the previous episode, we focused on descriptive statistics, frequencies, and cross tabulation. In episode 16, we are going to focus on t-test, ANOVA, and ANCOVA. So let's go to our data set. All right, this is our data set. Let me maximize this. As you can see, we have a few demographic variables, the items of different variables in our data set, and also the sum scores for different variables in our dataset. So IC stands for interpersonal conflict, RC stands for role conflict, PA is positive affect, negative affect, job performance, and JS is job satisfaction. So these are the sum scores for the items that you can see in this data set. Let's go to do some t-test analysis. To do t-test, you need to go to an analysis menu, and then from here, you will be able to select t-test. As you can see, there are 4 different types of t-test. In this video presentation, I'm going to focus on the first 3 types of t-test. So we start with one sample t-test, then paired samples t-test, and then independent samples t-test. Let's focus on one sample t-test. All right. When you select this option, what you need to do is to define your test variable and also the test value. Let me just select my test variable. In this example, I'm going to select interpersonal conflict. And the test value needs to be defined here. And what happens is that EQS computes the mean of interpersonal conflict and compares it with the value that you define in this box, and just shows you whether the difference between the mean of interpersonal conflict and this value is statistically significant or not. Let's define the test value to be 12. So if I click OK, I will be able to see the results. So my test value is 12. As you can see, I have 1,000 cases in my data set. The mean value for IC or interpersonal conflict is 8.087. And here you can see some descriptive statistics. And the important part of this analysis is here. So you can see that the mean for interpersonal conflict is printed here, and here we have the value, the test value of 12. So the difference between these two, we are actually testing whether the difference between the mean of interpersonal conflict and the test value of 12 is statistically significant or not. So here is the standard error, and as well as the T statistic, the degrees of freedom, which is 1000 minus 1, and the p-value. So as you can see, the difference between the mean of interpersonal conflict and the value of 12 is statistically significant. So this is how you will be able to do a one sample t-test in EQS. Let's focus on the second type of t-test, which is paired samples t-test. So normally for paired sample t-test, you need to have pre-test and post-test scores for your participants in your study. Since in this data set, I don't have any pre-test and post-test scores for the participants, I just assume that positive affect is in fact, or PA is in fact the pre-test score for positive affect, and NA, which actually is the negative affect variable in this data set, we just assume that this is the post-test for positive affect. So let's just select these two variables and put them in this box. So again, positive affect is the pretest score for positive affect, and NA is the post-test for positive affect in our demonstration. You can also define the test value here, but I just keep it simple. I don't define any values here so that you can simply see how, if the difference between the pre-test and post-test scores is statistically significant. So let's just click on OK. and then here you will be able to see the results. So for negative affect, or in fact the post test for positive affect, the value, the mean score is 9.335, and for the pre-test score, as you can see, it is 18.714. You can also see some other descriptive statistics for both NA, which is in fact the post-test for positive affect, as well as the descriptive statistics for PA, which is in fact the pre-test score for positive affect. And then here you would see you will be able to see the mean difference between these two values. All right, so it is minus 9.379. And since I didn't define any test value, that test value is actually zero by default. So this is the difference between the pre-test and post-test. And if you would like to see whether the difference is statistically significant, you can simply check the p-value here. So you can see that the difference between the pre-test and post-test for positive affect in this example is statistically significant. Okay, now if I had defined a test value, then here you could see the test value and the difference between the pre-test and post-test score, which was minus 9.379, was compared with that test value. We didn't define anything, that's why it's zero here. Now let's define a value for the test value to see the result, to see whether the difference between the pre-test and post-test scores and the test value that we define here is still statistically significant. So let's just go back to analysis, and then here third sample t-test. Again, I select positive effect and negative effect as pre-test and post-test scores for positive effect. And here I just define the test value to be maybe 6. All right. Now what happens is that again you see the mean score for the post-test and the mean score for the pre-test, and you can see the difference between them, minus 9.379. But here in the final section of the output, you can see that what EQS is doing for us is to test whether the difference between pre-test and post-test, which is minus 9.379, and the test value that we have defined, which is 6, is statistically significant. And again, you can see that this difference is statistically significant. All right, now let's go to the next type of t-test, which is independent samples t-test. So for this analysis, I'm going to select job performance as the test variable and gender as the grouping variable. Again, I can define a test value, but to keep it simple, I don't define anything here. So if I click OK, you can simply see the results of basic independent sample t-test. So the mean for job performance is 19.022, and for the first group, and for the second group, which has been coded with 1, the mean is 18.937, as you can see here. And whether the variances in this analysis are equal or not, you will get TA statistics with different degrees of freedom. And here also you will be able to see the p-values. So in both cases, whether the variances are equal or unequal across the groups, the difference between male and female people in terms of job performance is not statistically significant. So this is how you will be able to do t-test in EQS. Now let's focus on ANOVA. So to do ANOVA analysis, you need to go to analysis, and then here you have ANOVA option, and under ANOVA there are 3 options. So when your group sizes for your categorical variables are not equal, In fact, you won't be able to do one-way ANOVA and two-way ANOVA using these two options. However, if your group sizes are not equal, still you can do one-way ANOVA, two-way ANOVA, and also ANCOVA analysis using general linear model. So to show you that one-way ANOVA and two-way ANOVA cannot be done if group sizes are not equal, I just demonstrate this to you using these two options, and then we continue with general linear model. So let me just select one-way ANOVA. So my test variable is maybe job satisfaction. And I just select age group with 5 categories. And I know that the group sizes are not equal. So if I click OK, you will see this message. Independent variable has unequal size categories, which means that this analysis cannot be done if you select one-way ANOVA. If I select two-way ANOVA, I will be able to define my dependent variable, for example, positive effect, and then I will be able to select my independent variables, so age group and maybe current tenure. Again, if I click OK, you will see that the design is unbalanced. It means that cell sizes are not all equal. So this analysis cannot be done. However, if I select this option, general linear model, I will be able to do one-way ANOVA, two-way ANOVA, and also ANCOVA analysis, even though the group sizes for my categorical variables are not equal. So let's just quickly do the analysis. Let's focus on one-way ANOVA. So what I need to do is to define the dependent variable. So maybe IC in this example is my dependent variable or interpersonal conflict. Here I will be able to select the independent variable. So let's focus on age group. And if I click OK, I will be able to see the results, the ANOVA results, the main results, and also the Wald test of significance and the estimates of regression parameters. So basically, you will be able to see the results here. I'm not going to interpret the results because it's quite simple. And as I mentioned previously, my main intention is to show you that some basic types of analysis can be done in EQS. I believe that many of you can simply interpret these results, but in case you need assistance, you can simply go to the manual of the software or the user guide of the software. So this is the results of a one-way ANOVA. Let's do a two-way ANOVA in EQS. So to do a two-way ANOVA, you can simply select general linear model when the group sizes for the categorical variables are not equal. This time we focus on positive effect, and here I'm going to select gender and maybe current tenor. I just add them here, and if I click OK, I will be able to see the results. So again, you can see the ANOVA table here, the Wald test results, as well as the estimates of regression parameters. All right, now let's do an ANCOVA analysis as the final example in this video demonstration. So to do ANCOVA, you can simply select general linear model. You can select your dependent variable. Let's consider job performance as our dependent variable. For independent variables, you can simply consider maybe one or two categorical variables. So I just keep it simple. I just select age group, and for covariates, because I would like to do an ANCOVA analysis, I just select experience outside higher education. So this is a one-way ANCOVA analysis in EQS. If I select another variable and add it under the independent variables list, it will be a two-way ANCOVA analysis. And now again, you will be able to see the results. So some general information about the results. And then here is the analysis of variance table. Here you will see the Wald test of significance. Here you will be able to see the estimates of regression parameters, and similar to the previous examples, estimates of residual covariance, the statistics are displayed here. All right, it was all about t-test and ANOVA analysis in EQS. I hope whatever I shared with you is beneficial in your research. Thanks for watching and goodbye.